Hello friends, let's find the derivative of this function. And the purpose of this is we just want to see the need for another method for finding derivative. We already know the power rule. Why do we need another method called the chain rule? We are going to see with these three examples. Okay, let's find the derivative of number one. So using the power rule says that we call if f of x is equal to ax to the power of n, f prime of x, the first derivative is, I'm going to bring down the power which is n. So I have a times n, and I'm going to subtract 1 from the power. So I have x to the power of n minus 1. So using this power rule, I'm going to find the derivative of the first one. So I have um, f of f prime of x. For the first one, the derivative of 3x squared is just going to be 3 times 2, bringing the power down. Then I subtract 1 from 2, right? Plus the derivative of 1 is a constant. The derivative of a constant is 0. So this is just going to be 6x because 2 minus 1, 2 minus 1 is 1, which is just 6x. So that's the derivative of the first one. Okay, now let's find the derivative of the second one. So for this one, that's number 2. For this one, number 2. So for this one, I can't just find the derivative like that. What I can do is I have to first of all simplify this expression by multiplying 3x squared plus 1 by itself plus 1, then times 3x squared plus 1. So if you simplify this, if you FOIL, if you multiply everything out, you're going to get 9x to the power of 4 plus 6x squared plus 1. So if you simplify, that's what you're going to get. You multiply this by this first, then you multiply this by this second, then you multiply this by this third, that's the third step. Then you multiply this by this, that's the fourth step. So if you do that, then you simplify, you're going to get 9x to the power of 4 plus 6x squared plus 1. Now we can apply the derivative on on this term here, right? We can apply the power rule, sorry. So the power rule says that f prime of x is just going to be, so for the first term, um, which is 9x to the power of 4. Using the power rule, I can just um, I can just multiply 9, then bring down the power, which is 4, right? Then I subtract 1 from the power, right? So I have 4 minus 1. Then for the second one, right? For the second one, which is the second term, which is 6x squared, using the power rule, I have 6 times 2, x to the power of 2 minus 1 plus derivative of 1. 1 is a constant. Derivative of a constant is 0. So if I simplify this, I'm just going to get 36 x to the power of 3 plus 12x, and that's it, right? So that's the derivative of that one. Now, for the third one, right, the third function, which is um, f of x equals 3x squared plus 1 to the power of 2024. How can I find the derivative of this? Can we use the power rule? I think we can use it, but that will be cumbersome because I will have to multiply 3x squared plus 1, 3x squared plus 1, 3x squared plus 1. I'll have to multiply it by itself 24 times. That would be that would be too cumbersome. I will have to multiply 3x squared by itself 24 times. I will have to do this. So let me do this. 24 times. The dot means I'm multiplying 3x squared 3x squared plus 1 by itself, it's only 24 times. It keeps going. The dot 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 means I just keep repeating it, right? So, but that will be a lot. That will be a lot. So, in this case, the power rule will not be an efficient method, right? We can use the power rule, but it won't be an efficient method. So, this is why we need another method, which is called the chain rule. And using the chain rule, I can just take 4 steps and I'm done with the chain rule. So now let me write chain rule. So use chain rule, right? Just 4 steps. So the chain rule says that the first, so let me just write f prime of x. So the first step is I will take the derivative of what is inside, which is 3x squared plus 1. I'll take the derivative of that. If I take the derivative of that, I get 6x, the derivative of that, because the derivative of 3x squared is 6x, and the derivative of 1, which is a constant, is 0. So the derivative of what is inside is 6x. Now, then, what I'm going to do is that I'm going to bring down the power, which is, the power is what? Is 2024. I'm going to bring down this power. So I'm going to write it here. So I have times 2024, right? That's the second step. You bring down the power. Then the third step is I'm going to write what is inside here, just exactly what is inside there. I'm going to write it down. I'm going to write it. And I have 3x squared plus 1. I'm going to write it. That's the third step. And then the fourth step is I'm going to subtract 1 from this power, right? I'm going to subtract 1 from that power, and that will be the power of the 3x squared plus 1. So I'm going to have 2024 minus 1. So if I simplify this, I'm just going to have, let me say, 6x. I'm just going to keep this way, 2024. Then I have 3x squared plus 1 to the power of 2023. That will be the derivative of that using chain rule. So we see from here, we see the need for an efficient method, which is the chain rule, right? We just see the need because the power rule will not work for problem number 3. I hope this helps you see the need for chain rule. Thank you.